Hi everyone, welcome to week 9. We're going to start by continuing with radical expressions and the operations on radical expression. The first thing that we're going to look at is multiplying radical expressions with more than one term. The idea here is that of distribution. So for example, if you have a single term multiplying with two terms, you distribute the root 7 to both the terms to end up with root 7x plus root 7 times root 2, which becomes root 7x plus root 14. For examples here, that's going to be cube root of x times the cube root of 6 minus the cube root of x times the cube root of x squared. Now because they are both cube roots, I can combine them as cube root of 6x minus cube root of x cubed. And I can simplify them one step further. Cube root of 6x remains cube root of 6, but cube root of x cubed becomes an x. Now, if you have two terms that you are multiplying and you're following the process of distribution, you're going to have a total of 4 multiplications. When you perform these multiplications, be careful about the changes in signs. A positive times negative is a negative, negative times negative is a positive. Also be careful about the radicals. For example, if you have similar radicals, root 2 times root 2 becomes a 2. If you have different radicals, root 2 times root 3 becomes square root of 6. And then you can combine the like terms. For example, these are the like terms, which become negative 7 root 6, and 40 minus 18 becomes 22. There are some special products which we have seen before. For example, a plus b whole squared is a squared plus 2ab plus b squared. A minus b whole squared is a squared minus 2ab plus b squared. And a squared minus b squared is a minus b times a plus b. Here are examples how you can use them. If you do not want to do the distribution and you recall the property, you can just substitute these values into the appropriate property. Square root of 3 squared is 3. This is 2. These are different radicals, so they combine to give root 21 plus 7, which becomes 10 plus 2 root 21. Similarly, here it's a plus b times a minus b, so that's a squared minus b squared. 7 minus 3, 4, which is a rational number. Now keep this in mind because we're going to be using this particular property of multiplying a bunch of irrational numbers to get rational numbers later on in this week's video. Similarly here, that's going to be root a squared minus root b squared, or a minus b, which is also a rational number. Again, take note, we're going to come back to this particular idea later on. Well, the next topic is called rationalizing the denominator. Rationalizing a denominator is a phrase you will hear often in math. Let's see why we want to do something like this. Now, let's look at the expression square root 2 over 2. It is more aesthetic than the expression 1 over root 2. You can verify using a calculator that these in fact are the same. In addition, having the denominator to be a rational number, as in this case, makes it easier for operations to be performed. It also helps get rid of unwanted expressions, as we will learn later on. Case 1, one term in the denominator. Right. Motivation, recall, square root of 2 times square root of 2 is 2, or square root of 3 times square root of 3 is 3, and square root of a times square root of a is a, for any number a. Similarly, cube root of 2 times cube root of 2 squared gives me 2, or 3 to the 1/3 times 3 to the 2/3 gives me 3, or a to the 1/3 times a to the 2/3 gives me a, and so on. Basically, saying that if you have an irrational number, you can find a number to multiply it with so that the result is a rational number. Right? That's the first motivation. And then the second motivation is 2 over 2 is 1, or a over a is 1 for a not equal to 0. Any number multiplied by 1 remains the same. So that I can do the following. If I have 1 over square root of 2, which is an irrational denominator, I multiply it by square root of 2 over square root of 2. The motivation being that I can do this because that's just 1. And the reason I'm doing this is because then square root of 2 times square root of 2 gives me a rational number, which is 2. Let's look at some more examples. So here, I'm going to get rid of square root of 6 or make it rational. So I multiply by square root of 6 and I get square root of 30 over 6. Now for cube root, we're going to go back up here and see that for cube roots, we have to multiply by 2/3 to make them into a rational number. So that's cube root of 7 divided by cube root of 25. But in this case, I can make an observation that cube root of 25 is actually cube root of 5 squared. So what I have is 7 to the 1/3 and I have a 5 to the 2/3 already. Now to make this into a 5, all I need is a 5 to the 1/3. So I use that, which makes it 35 to the 1/3 over 5, and that's a rational denominator. So that's the end of this video. We're going to look at continued process of rationalizing